Good afternoon, everyone. So, I welcome you all for this day 3 of the Cybersecurity and Network Essentials training. Okay, I think still members are coming through. I'll just take up a minute's time. Meanwhile, if you have any questions, you can have through the chat box. I hope yesterday we have gone through essentials of TCP/IP, as well as we have gone through the other important areas on routing protocols. So, which is a very important area, especially if you are going for interview. And also, I have shared all the recordings in the drive. I hope you are able to hear my voice. Can someone respond by saying yes or no? Okay, that's fine. That's good. Thank you. Okay. So yeah, I just want to get any questions from you all. Meanwhile, before the members come and join the meeting. Okay, so in our yesterday's class, yes, what I wish to I was mentioning is the routing protocols. We also did an exercise on what we call as yeah, I was doing the same thing. Recap. We have just discussed about what we had discussed yesterday. Yes, Shonu. Like we discussed on TCP/IP, the first most important thing, and especially in the TCP/IP, we have discussed on the layers basically, like the TCP header and UDP header, the difference between TCP UDP, and also protocols also we could get through. Okay, like routing protocols. We spoke about what routing means. Very important area. Yeah, please ask doubts. Before members join, we can at least have some questions on the doubts. Please, the chat box is open. You can ask me the questions also. And meanwhile, I'm just recapping what all we spoke yesterday. So IPv4 changes to broadcast. It doesn't change basically, Rakesh. It doesn't change. Every network, as I explained, every network has a network address and a broadcast address. The network address is the starting address. The ending address is the broadcast address. In between, we call as valid IPs. In between, we call as valid IPs. So whether it is class A or class B or class C, every network has a network address, which is the starting address. And the ending address, the last address, is called as the broadcast address. As I can, wait, I was showing you. I'll open my notepad. See, if you take up any network, BSNL is a network, okay? Like Gitam is a network. Okay. Like anyone, like Andhra University is a network. We had a diagram also yesterday with help of, Cisco, that packet tracer. So if you say network A, any network A, which has the starting address, if I take the series as, I can take any series, whether class A or class B or class C, 192.168.1.0/24 means, when I say /24 means 255.255.255.0 is my net mask. Means that net mask means these 3 bits, these 3 octets, which we call as 888, 24 bits are given for 24 network bits plus 8 host bits. In that way, you have to think that 24. Whenever you say /CIDR, this is called CIDR, classless interdomain routing. So whenever you say /24, that is the number of network bits which has been set. Rest of the other bits are host bits. Rest of the other bits are host bits. So here we have 8 host bits. The maximum number of hosts in this particular network is 2 power 8. That is 255, 256. So here how do you define 192? Your network address. Network address is your network basically. Network address is what we call as 192.168.1.0. Broadcast address is the last address. Broadcast address is 192.168.1.255. This is my broadcast address. Okay, and in between we call as valid IPs or range. Valid IP range. So here you can see this is 192.168.1.1 to 255. This is my range. If I had taken class 24, I mean C class, the same thing. If I have a larger network, you see this, I'm taking this 172.16.0.0/16. If I take this network, so here this net mask is 255.255.0.0. So this is how I define. That means 16 network plus 16 host. Okay, 16 network and 16 host. And here the network address is say that 172.16.0.0 is my network address. Broadcast address is 172.16.255.255. This is my last. And range is 172.16.0.1 onwards to 172.16.255.254. This is how you need to understand. This is how you need. So 0.1, 0.2, 0. Up to 0.255, then 1.1, 1.2, 1.3 up to 1.254.5, and then again 2.1, 2.2, like that 255.254. You can have IP addresses. Is this clear about this explanation on this broadcast address? Please have a note of all these things. This is how. If you have a network C with class A/8, you will have a very large network address. I mean, here only 8 networks and 24 host IPs will be there. So 2 power 24 will become 4 million, 16 million IPs. Okay. Now there is again, Devjit is asking another question. When the router requests an ARP program, okay, it's not ARP program, it's an ARP request for host discovery. This ARP is executing in a gateway or switch. I didn't understand basically. Router doesn't request anything. Router requests for Devjit, you can switch on your microphone and then speak. I didn't understand the question properly.
Okay, sir.
Little bit louder.
So what happens is when there's a packet coming from another network into a host computer in a network.
Yes.
Okay, so initially it comes to the gateway, and if the it should relate, it should translate that IP address to the MAC address, right, sir, for transmitting the packet.
No. Okay, it will translate automatically. That the parent router will do, not from the other router.
Yes, sir, that's what I'm telling. The parent router in the network, which is supposed to receive the packet, will translate.
It will be there. See, when you see the packet header, it contains the MAC address also. Okay, in layer 2.
So there is a table called ARP cache, right, sir?
ARP will be there. ARP will be useful for the uniqueness of the, of the identity of the host. But the real communication will happen only with TCP/IP, internet communication. Like if you see, just see me also. If you see, frame is there. Frame is enclosed in a packet. Okay, number of frames are there in a packet, and that packet is segmented and sent it off. So while receiving the router receives all the segments and it dismantles, encapsulation dismantles, and you'll see the packets. When it enters into the system, after the system, then only the ARP will come. Router doesn't do anything. Router doesn't have even the vision of basically to see the MAC addresses. Only thing, it will be there in the packet structure. It will be there in the packet structure. Only the header part will be there. The data it cannot see, if it is, especially if it is an encrypted form. If it is not encrypted, then router or whatever, whoever there in between the communication also can see. Is this clear? I do not know. Is this the question which you have asked?
Uh, I'm asking a different thing, sir, because yesterday I was going through some internet material about ARP thing.
Okay. ARP has only one task. It basically translates or keeps your
IP
MAC
address
address
to MAC address.
to IP address. That's all.
So what I'm trying, sir, you need, so let me give you a scenario, sir. I will be better able to explain that way.
Okay.
So if there is a network with a switch that connects to a router and with 3 devices, okay, and then I connect one more device, so that device will be given a IP address for communicating. So that device which is new to the network will use RARP for discovery of its IP address.
Right.
So
Now I understood your question. Basically, if the devices doesn't have an IP on its own, and if it's trying to get an IP, then it will ask the router. This is also an RARP only.
okay, so that's what I'm asking, sir. If it is asking to the switch
That
or
is
the router.
DHCP. That is there is a protocol DHCP inside your router. So what does this DHCP does? I'll explain that. Anyway, we have that in a part of our syllabus today itself. I'll explain. But till now, you can understand that dynamic host communication protocol, that is called a DHCP. Okay. So when your router is also enabled with DHCP, you have a pool of IPs inside the router itself. Is this clear?
Okay, sir.
When you configure your router as a DHCP, it has pool. The word is called as pool of IPs. So whenever any device is connected to the network, it will raise a ARP request. Okay, so it doesn't have IP, it has only MAC address. So router will ask, hey, what is your MAC address? It will tell. So it will register that MAC address and it will give an IP to that. That is how you see in your system obtain IP automatically. Means that the router or DHCP server will give you an after taking the ARP request. Is this clear?
Yes, sir.
But for that you need to configure in the router, the pool, everything, the DHCP protocol. That is dynamic host communication protocol.
So that the ISP will take care of it, right, sir?
ISP will take care. Even your NAT routers which are there inside your home, it has DHCP also built in.
Okay.
You can see that. More information you can get through DHCP. Like I'll show you. So if you go to Google and say, just say DHCP. DHCP means it will tell you. It will tell you very clearly. The dynamic host configuration protocol is a network management protocol used on IP. Okay, where IP means it is basically on the third layer. So here, if you go through this particular one, it has a pool of IP addresses. Pool dynamically assigns IP address to other network configuration parameter each device on the network, so that they can communicate with other IPs. Is this clear? So this protocol needs to be enabled in your router. Anyway, that is a bit later, but understand here that you need a DHCP which handles all the ARP requests.
Okay, sir.
Okay.
Okay, sir.
Right.
One more doubt, sir.
Yeah, you can ask.
Yes, so yesterday when you explained the routing information protocol.
RIP, yes, dynamic protocol.
Yes, sir. So that uses distance vector algorithm for
Sorry?
routing. That uses distance vector algorithm.
That uses this distance vector algorithm.
So yes, sir, I have a doubt there. So when in that algorithm, essentially when routing table is to be formed, there are so
I will explain you, since you have mentioned the distance vector algorithm, how the algorithm works. I will explain. Okay. See here, like I can tell you in this way. I'm closing this box. I'm minimizing this one. I'll take this notepad. No, otherwise you can listen this way. Distance vector algorithm is also called as neighborhood algorithm. Neighborhood. What is yesterday I mentioned about neighborhood, which is also called as distance vector. What is vector? Vector is having both. I mean, magnitude as well as direction also. Okay. So in this way, with help of this algorithm, it will detect the neighbors, adjacent ones. The direction is known to. So That is how it basically understands. It understands you with help of multicasting. We call it multicasting. So there is a multicasting IP for that. So which uses 224.0.0.10. If you are little bit focused more towards networking, you'll understand a little bit more. But anyway, in this distance vector algorithm is like which basically tries to gain the information from the neighbors. Vector algorithm, and then it records the information. And also it multicast to the next. To the neighborhood routers. So in this way, if A has two routes, like I'll show you in the notepad. This is router A. If I say this is router B, okay, this has a known networks known. Okay, I'll say known networks of maybe I'll say 1.0 and 2.0. Here in router B, it knows about 2.0, 2.0 and 3.0. So when they have this algorithm configured, these are known networks which I'm saying. And what is the unknown things which are there? Unknown things we can say here for router A, unknown is 3.0. 3.0. Similarly for router B, the unknown is 1.0. If you have multiple networks also, it's the same. If I have one more router, so then more information, if I add one more router C, so I'll have more networks. So 1.3. This router may know about what is the 3 and 4. If I say like that, or 4.0 and 3.0 in this way. So now unknown routes will be more. 3 and 4 also is unknown, right? 4 also is unknown. Same thing here also. 1, 2, 3, 4 is also unknown. Here now 1.0 and 2.0 is unknown. Okay. So now what does this routing algorithm does? All the unknown networks, if it is known, then it is called as routing. Algorithm is done. All the unknown networks, making it known. So in this way, router identifies router A knows router B. So what is the unknown network which it has obtained? 3.0. But router B is connected to router A as well as router C. You can see the connections. Router B, it has 2.0 from the router A, 3.0 in the router C. So it knows about, it can get information about 1.0 from router A, 3.0 information, 4.0 information from router C. Same thing, router C also, how does it gain the information? 1 and 2 is unknown. So 2 is information can be brought from B. But how does router C get 1.0? Again, after multicasting, this router A gives the information to B. From B, it comes to router C. In this way, router C gains this information of 1 and 2. If it gains, then all the routers know about all the networks. This is what RIP does, routing information protocol. And this algorithm, if you go a little bit deeper, we call it distance vector algorithm. There are various types of algorithms. Distance vector algorithm is used in routing information protocol. Okay, vector means is the direction which is known in both ways. Okay, is this clear, Debjit?
Yes, sir.
Yeah, and there are various other type of protocols also, like EIGRP is there. There we don't use this. Alone this distance vector algorithm will not work. It will identify the neighbors, but there again multicasting is in a different way. I think. Okay, can someone share the WhatsApp group link? You can share. Someone can answer that. Okay, so in that way, like there are various other algorithms also which are there. We call it dual. In EIGRP, if you go, you have an algorithm called as dual. We call it diffused update algorithm. Diffused update algorithm. Where it gets diffusion, there is a pattern of what we call as the DR concept is a designated router. Like you have a centralized point. If anyone has a change, you update in administrative department. From there only, it will be multicasted to all the departments. Like this here also in EIGRP, it will be updated. It knows its neighbors. If there is any change, it will update the designated, not to the neighbors. Unlike neighbors, here all the neighbors should get first updated, and then automatically everyone gets updated. See, there are various type of algorithms. Even if you go to OSPF, you have a different algorithm again. Okay, linked state algorithm, we say linked state. So if you know about this Dijkstra diagrams, Dijkstra, have you heard about that in any of the college?
Yes, a single source shortest path
Yeah,
algorithm.
same logic it applies there, same logic. So I didn't go in detail about all those things because every algorithm needs to be understood. If you know the algorithm, then automatically it will figure out. I mean, how basically it can identify the destinations. So it uses the Dijkstra diagrams algorithm basically. And as I said that with that algorithm, even almost all linked state algorithm, any link changes are there, it will inform the I mean elected designated routers. So that is again another algorithm. If you see each and every routing protocol has its own multicasting address. Like EAGRP has, I think, to 224.0.0.9 is for this RIP, 5 is for EAGRP, 10 is for OSPF. Something is there. I don't remember exactly, but every routing protocol has its own algorithm. Is this clear? Please go through. Yes, I think you have gone through some of the slides. I really appreciate, and please go through that. You will really learn much more. And if you have any queries, yes, you can ask me also, no problem.
Sure.
You can ask me. Definitely, networking is a very interesting subject if you go through a little bit more. Yeah. Any further questions before we start for today's topic?
No, sir. I'm done.
Okay. Anyone else? I didn't see the chat box. I think Shonu is asking some WhatsApp group link. You can someone can share. Okay, so let me start with today's session. Today's session we will be focusing on what we call as this switching. Switching again is also a very important topic. But yes, I wanted to tell you that I have shared some interview questions also. See, if you are serious enough, yes, you will be definitely winning this type of interviews. Not only this, at any place, at any interview which you are attending also, it will be helpful. And yeah, see, thing is like I have already circulated this in the group drive itself, in the share drive, this networking interview questions. I have kept yesterday questions. I didn't give the answers. So I thought someone will ask questions after seeing the interview questions. But I have the answers also. But let me also, because there are many questions which are there. I don't know how you will be moving ahead in understanding each and every question. But I wish that everyone study this type of questions a little bit more, which will be helpful. It may be as simple question, but when you go a little bit down, then automatically questions will be going ahead a little bit tougher. Or I mean, the technical questions also will be coming across. Okay, so please understand this one. See, explain RIP. It's a simple protocol exchange between the routers information. It uses neighborhood algorithm or protocol. Whatever it is, what is subnet, what is MAC address, what is multiplexing, what is simplex communication, what is hard duplex, what is full duplex, sampling. See, not all the things I can cover everything. So that is the reason why I have shared you these questions. Maybe if you can go through these questions, that would be helpful. Please go through. And today again I'll share these questions. Please ask me also if you are unable to understand any by chance any of these things. Okay, CRC, Hamming code. Anything can be asked. CSMACD. Okay. What do you mean by Bluetooth? What is IP address? Okay. These are purely interview questions which are pulled out from some websites or from some industries. So sometimes you may get, they also do the same thing in order to get the questions. So they may ask similar questions only. Similar questions, FDM, frequency division multiplexing. Okay, TDM, time division multiplexing. So these are communication essentials which are along with your network fundamentals. So what are all the protocols in transport layer? Client server model. What is telnet? Okay, what is HTTP? What is www? What is RAID? Okay, is a basically redundant array of inexpensive independent disks. Okay, net BIOS, ARP, RARP. So several questions are there. Please go through this one. Please go through some of the things we will be discussing even till today also. Okay, so let me quickly go through this particular today's session, which is layer 2 switching. Yeah, any further questions before I start? Okay. So one more request from my side. Yeah, if someone can take a co-host role, it would be beneficial for me. Yeah, please, can someone who is interested to take the co-host so that whoever comes and okay, Tejashwini. Okay. I think why the waiting room is enabled, it's not everyone publicly is there. Participant can chat with. So okay, I have done. Take care. Okay, so let me start with today's presentation. Switching. I hope everyone is able to see my slide. Can someone unmute and say yes, able to see?
Yes, sir. Yes, sir.
That's good. So now in this, please understand along with routing, switching also we should know. Switching is basically we call as a layer 2, which normally, we already spoke on the very first day. Switching basically happens at the access layer itself, access layer. So what is essential in switching? We'll be learning about that. But first and foremost thing, what you need to learn is the functions of a switch, functions of the switch. So switch basically extends your network. It's a LAN device. Again, I'm saying it's a LAN device. It cannot distinguish networks. It cannot distinguish networks. Okay, I will tell you. Yeah, no, this one. It cannot distinguish networks. It doesn't have any recordings of the IP address. First of all, switch. All the systems we connect to a switch. Then what is the speciality of the switch? So these are the three functions. Please note down or take a screenshot or whatever it is. So this is very, very important. The first is that as soon as you power on the system, the system sends an ARP request. Okay, what is an ARP request means? Hey, I have a MAC address of so and so. What is my IP? That is what which is called as what ARP request. So can someone give me an IP address? So who will give me an IP address? I don't know. So then this switch will take up this MAC address, will note the MAC address and forward it to the router, and it will forward it to the router, and router will brings back. So what does the switch do? Switch basically records the MAC address only. It records the MAC address in the MAC table. Why it has a record? To identify that so and so system is connected to so and so port. It can be Bill or it can be Sally or it can be Sid or whoever it is. So to identify this, we have an address learning mechanism. If there is no address learning mechanism, if Bill wants to communicate with Sally, it has to struggle with all the ports and asking, are you Sally? Are you Sally? To all the ports. If there are 24 ports, all 24 people needs to be questioned. Like this, if I call for a purpose to you, then it is called as a faithful. I mean, it's a correct call on your telephone. If someone is calling you by, if I say that someone is calling you with a different name, Are you so and so? If you say no, I'm not, then it is called as a wrong call. It's called as a wrong call. If you are getting too many wrong calls, what will you say? It is a disturbance and discrepancy for you. You will not use that phone because all the unwanted calls are coming across, and it basically deviates the underperforms the performance. So similarly here also, when the ARP request is rightly fed, when these requests of MAC address so and so is noted down, Bill has to communicate to Sally means it has to go to Sally only. If it goes to somewhere else, then it will be a drawback. It will be a big drawback. It is called as even collision or underperformance of network. To avoid this thing, switch, the difference between a hub and a switch is the same thing. Switch has an address learning, whereas hub doesn't have. It will try to multicast each and every area. It's not multicasting, it's try to broadcast to all the ports in the network. Are you Sally? Are you Sally? To all of them. And everyone will say no. And last, finally, Sally will say, Sally, yes, I am. So again, if again another request comes, again it will struggle. So there are too many requests floating across, and you will see lot of collisions. To avoid the collisions, what we have done is that we have kept a address learning. Like the way you have a register of all the members in the classroom. Only those members are allowed, and those members are allowed to speak. So here also same thing, address learning is the first important feature in the switch. And the second most important thing is forward and filter distance. As needed, the data packets or the frames is forwarded to the next system, or it may be to the other switch also within the network. Other switch also. This is called as, otherwise if it is not found, it will filter it. Otherwise it will forward it also. Filtering means it is separation. The right word of filtering is separation. It will keep isolated, that you will not be disturbed by others. Same thing here also. So say, and the last and the third one is the loop avoidance. Suppose a situation like this. Bill wants to communicate with Sally. Sally is not there in that port of in any part of the switch. Okay. What it will do, it will forward the request to the other switches which are connected to that. So there it will search again. So after searching again, then there also it will not be there. The function is, if it is not available, go and search the other switches. So the same, that switch also taking the request, it will try to search, and then it will forward it to the other switches. Even it may include the parent switch also. So in that way, a loop formation happens. So this type of loop should not be there. If it is not available, and if it identifies the parent switch, it should tell no, it's not there, and stop the communication at this particular point. Is this clear? So these are the three very important areas of the functions of the switch, like address learning. Please remember, please by heart this one. We by hearted for the functions of router. We spoke about the day before yesterday, the functions of a router. There are 4 functions of a router. We spoke about that. Similarly, here also 3 functions of a switch. So if you know this, yes, you can understand the switch in a better way. And it again, I'm saying that the switch functions only in layer 2. It doesn't have it does not have network layer. IP layer. The switch doesn't recognize IP address. It has only the MAC address. Okay. So now I will also demonstrate basically the switch exercise, how you can connect. Yesterday we did a simple exercise of connecting the switch and the systems, and also we have demonstrated connecting the IP addresses to the systems and trying to communicate each other. So what is the protocol which is there in the switch? This is the protocol which is called as the spanning tree protocol. How basically spanning means you are basically increasing, spanning. It is going ahead like a tree spans branches, sub branches, and again like that it extends. Same thing here also, the switch, the root switch will be there. Okay, and then again switches will be there. It can be extended across the network. So how does the switch identify which one is the parent? By the trunk port or the root port which we call as the root. There is a root port, there is a designated port. Like every switch has a root port. I do not want to go into the technicality, just understand that there is something which is controlling the switch. That is called as a root port, which is controlling. You have 40 ports or 32 ports or 24 ports or 16 ports. Forget about all. There is one root port which is there. The root port manages. At a time, only one communication happens from port number 1 to port number 4, or port number 2 to port number 6, or port number 6 to port number 4, whatever it is, in whatever direction it goes, only the root port manages each and every communication in that. So for that, these things are there. So block port, forwarding port are all the technicalities behind, and we have a root bridge also. If multiple switches are connected, multiple switches, every switch has a root port. This root port is there, root port is there, root port is there. So all root ports form a root bridge. All root ports form a root bridge. What is the function of the root bridge? To see that any loop avoidances does not occur. No loop should form in between in the communication. Within the root port, you will see that effective communication between the ports. But when multiple switches are there, then the bridge will be formed, the root bridge. So in this way, the bridge will take care about all what we call as the loop avoidance kind of thing. So every switch port has the following status. Like you can configure as if by default it will be in listening. See, there are, again I'll explain, there are two types of switches in the market. One is the home purpose use which we use. These are called as simple plain switches. It has only two modes. One is listening, the other is forwarding. Okay, listening and forwarding. But there is again a second category of switches which is called as managed switches. Again, I specify unmanaged and managed. Okay, so when I say switches, you have unmanaged as well as managed. Unmanaged is the switches which you have at home. It has only listen and forwarding. That's all. So for listen means whatever data has come to the switch, it basically records your MAC address and then it sends it to the. It has to first listen and it sends to the relevant port. And forwarding means to the next port which will be done. But whereas when you say about a managed switch, I'll tell you managed switch also functions in the layer 2 only. There is no speciality. Layer 2 only. Layer 2 is access layer. But the extra capability is that it has some more features where you can log in into the switch. You can log in into the switch. It has an operating system where you can manage the switch ports. What you can do? You can disable the switch port or you can block the switch port. Okay? There are two more options here. You can disable the switch port or you can even block. So normally in a corporate environment, if a project is given, if a project has been awarded where it can be from a remote location, US or Australia or UK or Singapore or wherever it is, it can be Middle East or whatever it is. So the client basically manages all these switch ports. So from there, if he wants to block your port, he'll block you. And you'll not have access to the resources which is kept over at the client's end. So please do understand this one. Managed ports, they will directly log in into your switch. They'll log in into the switch remotely from there, or the network admin can do. He'll log in into the switch, he can block the port. I mean, not only blocking and disabling, he can assign the bandwidth of the switch. Many features are there. So this is called as managed switch. And also one more feature is there in managed switch, that is called as VLANs. VLANs. We spoke about spanning tree protocol. Spanning tree protocol, STP, which is a default protocol for all the switches. For all the switches, I'll tell you, any switches, the default protocol is spanning tree protocol. In this way, it extends. But now we are going ahead with managed switches. You have two additional, port states or status which is available. In addition to this one, in managed switches, you have one more protocol which is called as VLAN. We also called as VTP, Virtual Trunk Protocol. Virtual Trunk Protocol. Virtual Trunk Protocol. So what does this do? What does this do? I'll explain this. And we have a small lab. I'll tell you. VLANs means virtual LAN. Virtual LAN. See, today's world is switching faster or routing faster. Can someone say? Is switching faster or routing faster? Yeah, you can say or you can write it on the chat box. You should have some fair idea. Yeah, Mano says switching is faster. Sachidev says routing is faster. Okay. Any more answers? Say, I'm telling you, these all chat box, everything, whatever is that is recorded and it is being forwarded also to the management, to your college. They're just switching. Yes, you have some, most of you are saying switching. I'll tell you why. Switching is much, much faster. It is much, much faster. The switching, the latency is in nanoseconds. The switching, the latency is in nanoseconds. Whereas in routing, the packet header needs to be read. Okay. And the routing tables needs to be fetched. And then the packet needs to be switched. So normally routing takes in not milliseconds also, in seconds. It will take much time depending on the traffic also. But whereas switching is in nanoseconds, nano, micro, very fast. So today we are adapting towards switching rather than routing. Of course, routing has its own importance. I'm not saying, I'm not denying. So switching is much faster. So today we will learn about using this VLAN, how you can switch and create a virtual LAN. So virtual LAN, VLAN stands for virtual LAN. What is this virtual LAN? We will learn about this virtual LAN. See here, yesterday I was mentioning, yesterday you told us, sir, the LAN means it is a local area network where one system can communicate each other. Same thing. And also you mentioned that switch can only work within the organization. It will not even cross a different network also. Then what is the meaning of virtual LAN? Yes, I will tell you. I will tell you practically. So first thing is that I'll open a packet tracer where we can understand a little bit more. So I hope you are able to see my screen, packet tracer. Okay. So if I take any switch, I'll take a switch. These are all managed switches for your reference. Unmanaged switches are there in our home. You can go to market. If you don't say anything, he'll give you an unmanaged switch, which is very cheap, very cheap. I mean, how many number of ports? That many number of hundreds. If you are buying a 16 port, it will be about 1600 rupees or 2000 rupees. If you are buying a 24 port, it will be 2400 or 2500. Similar to that, I'm only giving a rough figure. That is the price of a unmanaged. But whereas managed, it will be more costly. Like if I say about a 24 port managed switch of Cisco will be costing not less than 50 or 60,000 or maybe higher. There is because of if you are having more and more features, more giga switch or something like that, it will be in 70,000-80,000 also. So I'll take a switch. This is a managed switch. I am just connecting some systems. Okay, 1, maybe 2, maybe 3. Okay, I am connecting more. If you have more time, you can connect more switches also. I'm not using router now. So here what I'm doing is I'm just connecting to the switch. This is port 1. Okay, I know I'm connecting to each and every port. This I'm connecting to port 2. And this one I'm connecting to port 3. Okay, just watch this one. Then you'll understand VLANs very clearly. Now you see there are 4 IP switches are there. 4. Imagine that you see like I can have more switches also here. Okay, I can have 2 numbers more switches like this. I can add a switch here and say I can add more systems. I can have a laptop or a desktop here. I can extend how many number of systems which I want. So from here, a straight cable to here. Okay, this is done. But whereas to switch, we need to adopt a cross cable. Why? Because both of them are DTE, DCE, DTE. You need to understand about this. These are all DCE devices, data communication equipment. These are all DTE, data terminal equipment division, equipments. Okay, so whenever there are both are same, DTE device, you need to have a cross. If it is the communication is DCE to DTE, it is straight. So that is the reason why I have given a cross cable here, cross cable. So I have connected all these things. Everything is working. Okay. Now also I am assigning an IP address. So here I am saying configuration. I don't have a gateway as of now. So I'll give an IP address of 192.168, maybe 1.10 with the subnet mask of 255.0. This I have assigned. And this one also I'm assigning 192.168 1.11 and this particular one also I'm closing. Okay, configuration. Sorry, no, Ethernet address 192.168.1.12. In a sequence, I'm giving this one 1.13. 192.168.1.13, and net mask is 255. This one I may give 1.20, something else, because I am in a different switch. Okay, I have configured. Now, if I say that, if I take this desktop and a command prompt, if I say if config, I can see, sorry, IP config, I can see my IP address is 1.10. If I say ping 192.168.1.10, it will ping. Okay, it's showing. It's getting a reply, it's communicable. And if I say about 20 also, it will do. There is nothing new in this. There is nothing new in this. So if I say 11 also, sorry, not 1. If I say 11, it will do. So I mean by default, switch is communicating to each and every device. Every device has its own MAC address. You can see here the MAC address. The MAC address is extreme right. You can see here, extreme right, 00D0, 58B2, 0944. Randomly it is giving. Similarly, all the switch records all the MAC address of each and everything. It has a MAC table. Okay, right. Even though it has IP given to the test systems, it will not. It doesn't have an entry to the IP address. Okay. Now this is done. Suppose like this, within the organization itself, you may have 100 switches or 50 switches or 10 switches like this, and it is distributed. You have given all the IPs. Now, if I say now the criticality comes. Please understand now the concept of VLAN. So this one, okay, if I say, sorry, this one, these two departments, if I say is these two systems come to a department called as finance. And this one may be a different department called as marketing. This is a remote person who is again a finance. Okay, you can equate even your college also. Maybe this is CS and this is ECE and this a location in the hostel where a CS student is there. So they want to communicate, but remember this one. These two here. Where is this tools? Okay, whatever it is. Okay, these two systems which are there, okay, is finance. And similarly, these two are again marketing. And now within the switch, you can have a virtual LAN. See now whatever this fellow is doing is able to access even this fellow also, these marketing people also. Then this finance people will say we have highly confidential documents, even though we are brothers in the same organization, but we want to have an isolation. Naturally, this system, otherwise they will not trust these people. In marketing also, we have a lot of bids which are going on, and you people are higher elevated people, you will trace all our documents and figure out all the things, and we don't have trust in you. But we are in a corporate land. And again, this fellow is also same branch. He should have access. Suppose as I have just shown, this fellow can ping here. So anyone can communicate. So in this way, now virtual LANs play into the picture. So what we can do, we can group these people to a different virtual LAN. We can group these two people in a different, so that even though IPs are same, it will not be changed. These two can communicate along with this person, but these two can communicate among each other, but not with these people, Is this clear? The concept, I'll be showing you demonstration. Then you'll understand better. So today's world, most of the organization has VLANs, especially your college also, whether you go to any organization, the grouping of departments is done only with the help of VLANs, and switching is much faster. Is this clear? Is this clear? Yes or no? Can someone say yes? Or in the chat box? Otherwise, I can repeat once again. Yes. Okay. So I got 2 responses. Yeah. So they just asked to repeat. Yes, I'll repeat once again. Please understand. If you understand the concept very well, then you can try to figure out the solution. right? Yeah, I will tell that. So here there is a switch, there is a switch. In this organization, in any organization, you have hundreds of switches extended to form a network. Okay, I'm not going beyond the network, within the network only. So here there is a department called as finance, there is a department called as marketing. You can have any number of departments, more than 2 also. Like you have your departments of computer science engineering, you have a department of ECE, department of IT, etc. You want to have your documentation among your people only. The finance people will trust only finance people, not the marketing people. Even though they are brothers in the same organization or sisters in the same organization, but they should have an isolation. They should have a security. So how the security can be done? With help of VLANs, with help of VLANs. Now if I say, as I have shown you, I can ping each and every system. Not only here, not only here, not only this, the other remote system also I can ping. But now how to group it and make a virtual LANs, virtual LANs. This is a virtual LAN, this is a virtual LAN. So this is a part of this virtual LAN. So how to do that? I'll be demonstrating. Go to the switch. These are managed switches. I'm telling, in managed switches, you have an operating system. You have an operating system. And once you power on, here also we call it switch operating system. These are mainly, mostly, from Cisco. And today there are many vendors which are there, which are very much similar to Cisco. All switches has the same protocol. Protocol is not different. Only the manufacturer, the vendors are different. Okay. So how you can define the switches? Please see this particular one, and you can understand a little bit more. What I'm going to do, I will create 2 VLANs, one for finance and one for marketing. Okay, and assign these 2 systems or these 2 ports to finance and these 2 ports for marketing. Then you see what happens to communication. What happens to communication? Okay, EN for enable. I have enabled the port. I have gone through, and I can say conf. Okay, VLAN. I am creating a VLAN. I can give some identity 10. Okay, name. I can say finance. Okay, I have created. Similarly, I'm creating one more VLAN which is called as 20. Name marketing MKTG. I'm giving a short one. Okay, so exit. Now, first part is that I have created 2 VLANs. You can ask to show VLAN means it will tell you. Okay, there are some default VLANs which are there, but anyway, the VLAN number 10 has been created. VLAN 20 has been created. By default, all the ports will be in one VLAN only by default. So that is the reason why all ports are communicated each other. Now, our task is to, since we have connected this system to 0/1, the second one to 0/2. So these 2, I need to move to finance department, and 3 and 4, I need to move to marketing department. Then we will see what will happen. So the rest of the other systems can communicate among, but 1 and 2 can communicate each other, but not with 3 and 4 because they are in a different virtual LAN. The ID is here 10, 20 are 2 different IDs which are there. Is this clear now? The task what we need to do? Our task is to shift these 2 ports to VLAN 10. Similarly, 3 and 4 ports to marketing. Then you see the response, what will happen. These 2 can communicate, but not with these 2. This is the highest level security, port level security. No one can go into the network room. That is one of the reasons why you will never be allowed to the network room. You will never be allowed to the network room, because if you disconnect and connect to some other area, you may get access to a different location. So they will not allow you. Every LAN, VLAN is configured inside the switch, and from the parent switch, all the cables go through. Is this clear? Okay. So now let me move ahead to this switch. We have already created VLAN. We need to basically switch the ports of both the interfaces. Okay. I'll show you how you can do that. So conf interface, the first one is FA 0/1. This is my interface. Interface FA 0/1. I can say that switch port mode. These are access. Which one? Access ports. Okay. Switch port access VLAN 10. I am providing for FA 0/1 VLAN 10 access. Yes, done. Same thing, interface for FA 0/2. Switch port mode access. Switch port access VLAN 10. So now you see what happens is, right, I'm saving show VLAN. You see this FA01 0/2, it has been configured into VLAN 10. Now it's no more in VLAN 1. Similarly, I will transfer 3 and 4 to marketing department. Okay, marketing department. I mean, so conf interface FA0/3. Okay, switch port mode access, switch port access VLAN 20. Exit interface FA0/4 switch port mode access, switch port access VLAN 20, and I have completed. Write memory show VLAN. It will show you now. FA0/1 and 0/2 are in finance, marketing, and this one. See, you know, in the industry, a network administrator or a cloud administrator or cyber security administrator are paid very high, and they are given highest respect also. It's not like normal software engineers. You will be a boss. You will be in a commanding situation. If you start the program, then people will follow you. Why? Because the only reason is that you have the complete control of the infrastructure. The only reason is because you have the control of the infrastructure. Not only you, your fellow mates, your bosses, your client, everyone will run behind you. That's why your importance is there, and you are highly paid for that. Only thing, you need to understand the technology properly. This is one gray area where people think that no, something is going on, we don't know. Nothing. If you know the logic behind, especially networking and switching, you can become easily a network administrator. And probably today, the physical networking is in the data centers, or maybe in your what we call as in your local area networks, etc. But whereas your virtual networking is done in the cloud. That's all which is happening today. If both of them are very much similar, only thing, you need to handle the resources properly. Now we need to test now. So these two are now in VLAN 10. These two are now in VLAN 20. You see this now. I'm going to the terminal prompt now. You know this IP. This is 1.10, 1.11, 1.12, and 1.13. You see this ping 1.10. Of course, it is self-pinging. Okay, it happens. 1.11, it happens. Both of them are their colleagues. But whereas if I say 1.12, it should not happen. It should not happen because they are into a different department. They are in a different department. It will not happen now. Is this clear? The same thing with 13 also. It will not happen. It will not happen. Okay. Okay. But if I say this fellow, marketing fellow who is there, you know his IP. His IP is 10, 11, 12. Okay, 12. IP config. His IP is 12. So he has to communicate only with 13, not with 10 or 11. You can see this ping 192, 168, 1 dot. If I say 10, sorry, it will not communicate. You are a different department. So if a member from marketing comes to finance and tries to access anything of his resources, do you think will he get access? Sorry, no. Because it is mapped to a switch port unless if he removes the plug and he keeps there. That is impossible. He cannot drag the cable to a different department. It is physically apart. Okay. But if he says like 1 dot, so here he is, 1.11 and 1.12. So his ID is 12, 10, 11, 12, 13. Let me try with 13. You see this, both of them are communicating. So in this way, it is very, very safe. The switching protocol, this is how VLANs work. This is how VLANs work. I know it will take time for you to practice and learn, but at least understand the logic of how VLANs work. That is what is my intention is. And that is what my intention. Is this clear? I will speak about the subnet part later, after this. Subnet is something different, whereas VLANs is something different. We don't use subnets. We have VLANs now. Okay. Is this clear? Yeah, I want to take this. Is this clear? Yes or no? If marketing wants resource of this finance, then only one way, establish a router. You have to route again. The VLAN 10 needs to route with VLAN 10, VLAN 11, right? Certain specific VLANs will be controlled in that particular way. If they want to have a communication again between these two, then there should be a router at the top. Okay, so such type of routers is called as L3 routers. Sorry, L3 switches. Sorry, once again I'm saying it is called as L3 switches. VLAN, inter VLAN. Here VLAN 10 is there. This is VLAN 10. This is again VLAN 20. If you want to route VLAN 10 and VLAN 20, you should have a layer 3 switch. See, again, I show you here in this, we have a layer 3 switch also. This is called as a layer 3 switch. This one, this is a multi-layer switch. You can see this one. What does layer 3 switch? It's not network layer. It is a layer 3 switch. What does it do? It basically routes your VLAN 10 and VLAN 20 also. You can write it here, but not in these switches. This is a different kind of switches. Is this clear? Layer 3 switch. The difference between layer 2 and layer 3 is in layer 2, you can have VLANs separated, but in layer 3, you can have inter-VLAN routing also. The routing concept also will be there in this particular one, but not for IP routing. It is for VLAN routing. Is this clear? Yeah, any other questions? Yeah, any other question? The other finance system, how do you know he cannot access? See here, there is one more finance who is sitting in the remote. Now, how to do that? That is my next exercise. This fellow is in VLAN 1. This fellow is in VLAN 1. This fellow is in, these two are in VLAN 10. Now we have to enable or push this fellow also into VLAN 10. Then only this fellow will communicate. What is this IP of this particular one? This one is, I think, 20. Let me see. This is 20. If you say this particular one and ask whether you can ping to this particular one, sorry, he will say 20 is not pingable because he is in different VLAN 1. So how to make it pingable? You have to basically extend your VLAN information to this switch and then communicate this particular one. Okay, for that, is this clear till now what I have spoken? I'll speak about the other finance. Yeah, okay, good. So now let me complete the other question, other answer also. So how you can extend your VLANs to the other switch and make him also bring into finance team. So that is again a big challenge. For that, you need to configure your VTP, which is also called a virtual trunk protocol. So now this will be completely in trunk mode. This is called a trunk. This is called as access. This 4 which are called as access, this is access. This is called as trunk. So now which port I have configured? You need to know that which one you have given this one. When you see this diagram, okay, when you see this diagram in configuration or in physical, so this is how your ports are there. Last port I have connected to this particular one. So now I need to specify this CLI mode and say that port 24 is not an access port, but it is a trunk port. It is a trunk port. And then I have to push this VLAN information to the second switch. Again, listen, I have to push or I have to share the VLAN information of this one to this switch. How do I do? By using this VTP protocol. Okay, I'll show you how you can do that. Okay. So here, what I'm going to do, if I say show VLAN, it will show you. Show VLAN. See, the only difficulty in this switch is that there is no CLS command. That's why they will not allow you also into the room. Even if you are entering into the network room by any chance, the network administrator will ask you to hold at the door itself. The another drawback is that the passwords are visible. Whenever you are typing here on the screen, the passwords are visible. So that is one more. There is no CLS, the passwords are visible. They will not allow you under any cost. to enter into that, because once if you see that, you can log into the switch. So that is the big difficulty. So show VLAN, this information needs to go into switch 1. This is another switch which is there. So here if I say EN and if I say show VLAN, there is no, I mean, finance or marketing here. We need to get the information first. There is no, but this is by default which is there. So we need to first get the information. How do I do? I have to make this as master and this has, I mean, a slave, kind of like connectivity, so that this master will push the VLAN information to the slave. So how do I do that? Just see this. See this. It's not important for the exam point, but for your understanding point. So how this basically real time, how it works. If you know this much, and if you can do this much, this is what which is really required for a network administrator. All the, I mean, 50,000, 75,000 or 1 lakh per month, they are paying only for this. Maybe a little bit higher. That's all. If you are familiar, most of the time you'll be managing the projects. One project has come, sir. Okay, assign a particular range of IPs to the router and then create a switch port. So this one VLAN is assigned to that project and VLAN is being distributed. All the things are ready. So now here coming back to config, I'll say interface FA 0/24. This is of course a trunk port, switch port, mode, trunk. This is a trunk port. Okay, it has changed to trunk. Switch port, trunk, allowed, VLAN, all. I mean, I want to push all the VLANs using port number 24. Okay, exit. Okay. Now, VTP. I can ask this particular one. Before that, I'll show you. Okay, before that, show VTP, virtual trunk protocol. It will tell you. So, VTP status. It is showing you this is virtual trunk protocol. Currently, it's in mode server, but nothing is there. Domain name is not there. Disabled. Everything is disabled. I have to enable this particular one. Okay. How do I enable? Conf VTP mode trunk mode server, which is already a server. Okay, which is already a server. VTP domain. I can say Githam. Okay. Earlier it was null. It has changed to Githam. Okay. VTP. I think that's all. That is enough. Automatically, then it will be enabled because port number 24 is already defined. So end. Okay. Now you see from the other side. What will happen? We have to define this VTP mode not as server, as a client. So VTP status. So here you see this, it is still in server. We need to change the operating mode. Config VTP mode client. Okay, now it is selected to client mode. And VTP domain already it is recognized to Githam. It has distributed accordingly. Now interface FA 0/24 switch port. You have to define this as the other side also. Mode trunk. Port, trunk, allowed, VLAN, all. Okay. Now, if you ask show VLAN, you can see the VLAN information of finance and marketing available in switch 1. Now, change this one to whichever port you want into finance. I will change the port to finance now. Config interface FA 0/1 switch port. Interface switch port mode access switch port access VLAN 10. Okay, now done. You can test now. He's also a part of finance team now. This fellow's IP is 10.20. Let me see whether he's able to ping to 1.10. Ping 192.168 1.10. Yeah, it takes some time to connect. Now it is connecting. If you see this one, because the VLAN has to synchronize information, VLAN 10 is 10 is connected, 10, 11 is also a finance team. But if you say 10, 11, 12, it should not connect. It should not connect. It will not connect now. Okay, request timed out. Is this clear now? Yeah, it will not. Is this clear? So this is very, very important, especially if you want to become, especially if you are if you want to become a role, especially in the network administration, whether you want to become a cloud administrator or network administrator or anything, this concept needs to be clear. And in every organization, wherever you see, whether it is IBM, HP, or Cognizant, Wipro, anything, wherever you go, you have VLANs. For every project, you have a VLAN. And within that VLAN only you work. Within that VLAN only you work. So this is how totally isolation will be there. Isolation will be there between project to project. The next person may be sitting beside you, but definitely you cannot ping even his system also. The IPs are again assigned from the router only, but you cannot ping. You cannot ping. The very reason because is the VLANs. VLANs. So in VLANs, you need to understand about VLAN and VTP. So these are the two elements which are there. Is this clear? Okay. So if there are any questions still, you can ask me. This is how I have showed you the demonstration. I hope it is understood. And we have some videos also. You can see that how you can create your VLANs, etc. You can go to YouTube also and you can search about how to create a simple VLANs. And you can familiarize. The Cisco packet tracer is a nice demonstration package. You can do the entire networking, including switching, routing, everything. Your firewalls, security, VPN, everything you can do in this particular packet tracer student, which is very, very handy. Okay. So now that's good. So I'm closing this particular one. I'm not saving. So this part is about switching. If you understand about VLANs and VTP, that's good. That's my presentation in what we call as switching. These are the four elements which you should understand about this spanning tree protocol. We spoke about VLANs also. VLAN is a logical grouping of network updates and resources connected to an administrator defined ports on a switch. Okay, based on functions or whatever it is, we can simplify these things. I'll share this presentation also. You can go through these things. Okay, not more, not much. We also figured out that, see, if you are asked a question like what is the difference between layer 2 switch and layer 3 switch, how do you answer? Can someone? If it is lengthy in the chat box, yes, you can. You can unmute your microphone and then answer. How do you differentiate, or what is the difference between layer 2 switch and layer 3 switch? Yeah, what is the answer? Someone? Read that these are interview questions. Anyone can unmute and then speak also, no problem.
Sir, in layer 2 switch, it's only work with MAC address, sir.
Sorry? Yeah, please say once again.
Sir, layer 2 switch only work with MAC address, sir.
Okay.
And it does not interact with higher layer address.
No. It's not complete, but you need to reframe the sentence. So I think someone has answered. Can you please send the record? Layer 2 switch enables us to work on intra VLANs, but layer 3 switches inter VLANs. Yes, I can take that. See, in layer 2 or layer 3, it works only in what I call as the MAC address only. There is no something specific. In layer 2, you have plain, you have VLANs, but you cannot have routing. The routing will not be there in VLANs. But in layer 3, you have VLAN routing also is enabled. That is the key difference between layer 2 and layer 3. Okay, is this clear? Layer 3 enables us to communicate with inter VLANs. I can take that. You can say routing or you can say communicating. Is this clear? Yes. I think what is your full name? What's your full name? Who has answered? I could see the initial only. Vamshi, Sri Vamshi. Yeah, Vamshi has answered correct. Vamshi has answered correct. See, such type of questions will be asked, unique questions. You can answer anyway. You have to first try to attempt the answers. So then you will definitely get through. So this is how your intra-VLANs, intra-network is within your network. You can have VLANs, you can have departments, etc. But routing can be enabled in layer 3 switches. Okay. So that is about what we call as yeah, it is already shared. I think if you have the Google Drive link every day, again I'm saying that every day the recordings are shared soon after the class. Soon after the class, you go to Google Drive, which I have given the link. I hope everyone has the Google Drive link. I had circulated through email and also through WhatsApp also. So you can see that, you can see in drive.google.com, you have all your information, which I have placed it yesterday itself. I don't know whether you have seen it or not. Where is this Geetham cyber security? So you can see like this in Geetham day 2, all the recordings are there. And with additionally, there are many important things also. If you are going through the regular basis, you'll get it. You'll get it. See here, what all I have shared yesterday, you can see this one. The day 2, the complete recording is there. The day 2 complete recording 436 MB. You can go through, and the information like routing.pdf is there. Network interview questions also I have shared, and also 100 interview questions which I am showing you just now. That 100 interview questions also I have shared, and 3 routers which we have done yesterday. That video also I have shared. How to create a 3 routers also. This is a dynamic route, and this is of course how to create 3 routers. Everything is shared in this. Please try to see whether you are able to access. Whether you are able to access using this link. Even I will not be again sharing again an email or something like that. That is enough. I think within this day 3 means you will see again day 3. Every day we have the recordings. If you want to see the day 1, yes, it is there in day 1, and all the technical notes which I had sent, the links which I had sent, whatever is that, whatever we have discussed. After the class, we'll be again sharing the other things. Is this clear for everyone? Okay. So use the same link. I'll be proceeding. If it is for day 3, I'll be giving the day 3 link. Okay, now we will move ahead with another important topic. Switching we have done a little bit fair. I know that I'm moving a little bit fast, but yes, we have a huge amount of contents to this one. This is only essentials which we are learning, not in detail. So here, today's topic is switching. First, we have done about the switching, right? And also, we have some more things also, like ACL and NAT also we will learn, and then we have IPv6 also we have to learn now. IPv6 also. Okay, so this is for today's agenda. Basically, like you can classify this one IPv6. Okay, so please understand this one. We spoke about VLANs and of course the VTP also, virtual trunk protocol. And now let us focus on ACL. ACL stands for, what we call as access control list. Access control list. I will change this presentation to access control list. Okay, we also call it security. This is very, very important, especially if you are going for cyber security also. This is network security. We also call this as network security. So I will not go much detailed or deeper inside this, but this will help you to understand about how the security is built inside the network. So here, if I say this one, first thing what we will understand is about the security, and then we will learn about what is NAT also a little bit internal. So here you see this is a corporate network. Corporate network is called as a trusted network. There are two kinds. Whenever you say internet, it's untrusted. Intranet, trusted. In our normal terminology, corporate networks are also intranets. Intranets are trusted networks. Means you have a private addressing only, not public addressing. Public addressing is called as internet, and it is untrusted. Untrusted means anyone can make use. Public, general public also can make use. So normally this corporate data, like you see this IBM or HP or maybe State Bank of India or maybe anything, whether it is a banking or any segments which are there, they prefer or they go only through trusted network. So now you see this one here, internet is there, which is untrusted. And people may come across via internet to the trusted network also. Okay. Or these people who are working in a specific area, this is how the organizational network is. Like you can see DMZ. DMZ is nothing but a demilitarized zone. Please make a note. DMZ stands for, this is a guaranteed question in your interviews. DMZ stands for demilitarized zone. DE. Okay. DMZ. I'll explain you what is DMZ. Demilitarized. Okay. What is this demilitarized? The name itself. There is some. 1 second. Demilitarized zone. Okay. So the name itself, military means something stringent. Something stringent. Pakka. They have something more in a controlled, which we can say. Why we should have? If you don't have a DMZ zone, then the attackers may come from the internet and attack the corporate networks. It so happens. Only thing is the bottleneck to enter into this network is the router. If they come to know any weakness inside the router, if they come to know any weakness in the router, they can attack all the servers, along with the servers also the internal network. Internal network means the resources inside the person who is working across in their desktops or laptops. Also they can attack, they can even snatch the corporate information, the corporate private information. So that is again dangerous. So but these people, the employees may send emails, may even access website. It is both ways. Outsiders also coming inside, or these people also accessing outside thing. So is this, then if they are able to access the internet, then how can this be called as a trusted network? So naturally, even though you have a corporate trusted network also, there needs to be a security, a kind of security. And who will take care about the security? It is again a router itself will take care about the security. And it is called as a firewall. Some people call it a firewall. And these things are monitored across, are well placed, segregated in a DMZ. They are well placed. They know that these are all the crucial, like anything organization facing, sir. Internet facing organizational infrastructure like email ID, web server or DNS server or something like that. They are placed in between both. I mean, in between both means corporate people also use, outside people also use. See, I go to SBA, online SBA banking or ICICI net banking from internet. This is one way. Same employees also work from intranet. They are coming from the trusted network. So do you think that both has same privileges? No, we have some privileges, but it needs to be regulated, monitored, each and every transaction, whether it is genuine or not. Otherwise, what will happen? The attacks happen in the corporate trusted network. So they segregate all the internet assigned facing servers separately, which is called as a demilitarized zone. And they continuously monitor across a firewall. So you see this one, this is a firewall. Firewall is also a kind of router, but it has stringent rules. Stringent rules. What type of rules they have? Suppose no FTP can be done from outsider to inside. So for what these people, they want some corporate information from outside world, that is internet world, or some emails. So firewall filters what are all the attachments which are there. This fellow outsider can send an email with a Trojan attached and then send it to the corporate. So if the Trojan enters into the corporate network, what will happen? These systems will be hacked. To avoid such type of thing, firewall reads each and every content, and filters out which is nonsense and then sends only the relevant things to the corporate or trusted network. Especially these are all internet facing like web server, mail server, etc. And these are to be monitored DMZ. What happens if there is no DMZ? So web server is maintained by some department, mail server is some department, or everyone will have their own. I am owning this one, I am owning that one, and everyone will be living in their own world. What will happen? Outsider will not see those differences. They'll come and attack every department. So for that thing, they have been all internet facing components, whatever the components for the organization, they keep it in a DMZ. So please answer this DMZ whenever it is asked very clearly. Demilitarized zone. And the two elements which are there, today we are learning security means we are learning the firewall. So in firewall, what will be there? We have rules. Those rules are called as ACL. Those rules are called as ACL. ACL stands for, all right. Okay. Access control list. Okay. So these are nothing but the rules which are written inside the firewall. Just remember that the rules within the firewall is called as ACL. So here the rules are of two types. What is called as allow or deny. That's all. There is no in between. Do you want to allow a particular service? Deny. Write it across. Port number 21. Stop. Deny. That means no FTP in the organization. Port number 80. Allow. Okay. You can allow. I mean www browsing can be done. In this way, you can write the rules. Allow or deny. That's all. There is no other in between kind of thing. And what all things you can do? You can specify a network or even a host, whether to allow or deny. In this rule, I am telling about the rule syntax. Whether you can allow, deny so and so network means that network cannot communicate to this network. Okay, or deny only a specific host in a particular network. You can do that also if you know the IP range. Okay, I think there is some questions which are there. I will say ACL is list. ACL is the rules. I tell you the rules inside the firewall. Okay, the rule set we call as ACL. Right. Security is yes. It is security is configured in the firewall only. These ACLs are nothing but firewall. So firewall is not a specific device. A router which bundled with some rules is called as a firewall. You have the network protocols, all these things. Above that, you are writing some elements more. You have the infrastructure. You are trying to say that whether this can be allowed, that can be allowed, or this cannot be, this can be denied, or that can be denied, whatever it is. This network should not come, or that network should be allowed. Those things are nothing but rules. Okay. Those rules are written inside your firewall. So these are called as access control lists. These are called as list. ACL is basically access control list. Is this clear? Mainly to protect your assets. In whatever way you configure. The rules can be added more and more. The first rule is here, the second rule is here, third rule is here, fourth rule is here, fifth rule. The rules keeps on adding more and more. But the system reads rules from the top. So the latest one will be at the top, it will execute. So today you say that port FTP is denied. Tomorrow you say allow. Day after tomorrow again you say denied. Again you say allow. Then finally what will be done when execution, whatever is the top rule, if it matches, it will allow. That's all. You can amend the rules like our constitution. You have a rule earlier something, now you have a rule different. Again like that. Firewall rules also can be amended or appended. So once the rule is matched, it will execute. Is this clear? Is it clear? ACLs? The firewall rules are also called as ACLs. Or rules, ACLs are also called as a firewall. What is there in the firewall? You have ACLs, control lists. We also called as lists in short. Access control list or list. Okay. Is this clear? Yes or no?
Yes, sir.
Okay, that's good. So if you want more explanation, I can do. Okay. So now the lists also can be like I told you, the rules means allow or deny. What allow or deny? For network and host. You can allow a network or you can deny a network. Or again, I tell you, the ACL rules are again two types. One is standard rule set and the other is extended rule set. What is standard rule set? In standard rule set, you can allow or deny a particular a host or network. That's all, nothing more. Okay, in standard, whenever you are writing standard rules, you can allow a deny a particular host or a network to communicate with you. So I have a network. I have my network, maybe a Geetham network. In the corporate firewall end, what I do, I write a rule. So and so employees or so and so network is not accessible, should not. Members from steel plant, no. So no, denied. Members from so and so can, yes, accepted. A specific members or the entire members, you can write it. That is a standard list. Okay. And then you have another one, extended, a kind of extended rules. In extended rules, you have a little bit flexibility. You can have allow, deny, allow, deny, and also host or a network, that also is there. Apart from that, you have one more additional component which is called as port or a service. You can define, there is more, a little bit more extension. I mean, you say that you are denying a network with port number 21. Rest all are allowed. Is this clear? You are denying a particular network with port number 21 means FTP is not allowed, but browsing is allowed. Or port number 80 is allowed. This is called extended rule set. You have a little bit more. Here means all the services are denied. All the services are denied. If you say a deny rule. If you say allow, then everything is allowed. No, I didn't understand. The difference between ACL in OS and CN. OS and CN. I didn't understand. Please, you can speak voice. Vamshi, you can speak so that I'll understand better. Okay, let me explain once again. See these rules. Okay, rules can have either allow or deny only. I said again. I'm saying it can allow, deny either to a network or a host. And ACL has two types of rules. Rule rating. One is standard set rule rating. The other one is extended rule set rating. Okay. In standard rule rating, you can have allow or deny to a host or a network. Okay, to a host or a network. Whereas in extended, we can have allow or deny to basically host or a network. Apart from that, you have one more additional component which is called, you can even define a port and a service. No, I want to have a telnet to a specific host. You can have that. Rest all no. To a specific host. Telnet is a service. Rest all services no. You can define that. FTP, you want to deny, but you want to allow something else, SNMP or SMTP or something else you can have like that, but not completely. Here, deny means everything is denied. So that is how you define this extended one. Okay, yeah. If you want to ask still question, yes, you can ask. This is how you consider the rule set. See, whether it is operating system or whether it is network, ACL means rules. ACL means rules. In networking, the rules are nothing but firewall rules. Okay. If you are speaking in operating system, the rules in operating system is different. If you are going to a swimming pool, the rules are different. If you are going on a traffic, on a highway road, the rules are different. It's not same for both. Okay. So the way you understand, because if you are speaking about an operating system, it is only just for a system, and that too for an operating system, not for anything else, not for even network also. Here we are speaking about the network. So network level we have to imagine, not at the host level. So we have to speak. But specifically, when I am sitting at Geetham University, the corporate network, the network means at the top level. So whether to allow the other networks, yes or no, which network you want to allow, that particular thing which you say. If you want to allow, which port you want to allow, so that you can even sit at home and access the college resources specifically. So these things are called a standard or extended rule service. Is this clear now? Is this clear now? Demilitarized zone is nothing but classification of internet facing servers to a particular area. Classification, one line if you want to ask me, demilitarized zone is classification of internet facing servers which you own in a corporate like web server, mail server, or DNA server or whatever it is, or even your Active Directory server which are used, which are internet facing, and you are classify and you are continuously monitoring these particular assets. Why we monitorize? Because those are internet facing and needs a highly protection, for mainly for high protection. So that is why we generally classify as demilitarized zone. If it is not classified, then anything can happen. It's not that I have not classified, the other fellow, the other department has done, because of that I am getting punished. It so happens. If there is a classification, all these things will be equally distributed across the corporate network. Is this clear, Vijay?
Sir, DMZ is a classical network, sir.
Sorry?
DMZ is a classical network.
It's the same network. You are only classifying the servers, internet facing servers, nothing else.
Okay.
Some services require internet as well as intranet, right? Like your web servers. Web server, outside people will access the website, internal people also will access. See, if you say, I go to online SBI.com or ICICIbank.com, I access internally also. Internally means intranet. Okay, the bank employees access intranet. But outsiders, I also access internet banking. So these are internet facing servers. So these things should be protected. Outsiders can do whatever they want. They are in an untrusted network. But those people has highly secured. They are, secured in a way of authentication, because the employees are there. They are tracing fingerprints. Everything is there. So there, the protection of assets, IT infrastructure is very much essential. So what they do, all these servers which are facing internet, they classify and they keep it. Each and everything which is coming from outside or internal, they will monitor that. They will monitor that. If it is accessing through the rule set proper, then they allow. Otherwise, they will discard the packet. If someone like me sends or upload a Trojan, instead of uploading something, if they ask you to upload an Aadhaar card, okay, instead of Aadhaar card uploading, I can upload a Trojan also. Will it sit inside the server? So who will monitor that? If it goes into the server, what will happen? The entire system will be getting Trojans and virus, and then the entire network gets collapsed. There are some people who do mischief like that. So who will monitor? So the firewall will terminate it. That particular type of document, it will validate and it will terminate it immediately. It will not allow into the corporate network. So that is how it is done. Once if they have a militarized zone and a firewall placed on top of that. Is this clear? Vijay and others?
Yes, sir. Yes, sir.
Okay. So yes, Vamshi, is your doubt clear? Okay. So okay, this is about in brief, which I wanted to tell about this, what we call as, otherwise all the attacks will come through. DOS attack, I will be explaining about DOS. From tomorrow onwards, we will be going towards cyber security. Okay, last 3 days till today, we were doing on network fundamentals. Next 6 or 7 days, which we have, we will be covering the cyber security essentials. Okay, so just focus on these things. So appliance of IDS and IPS, all these things, attacks and all these things happen if the security is not proper. Security proportional to less security, more attacks. More security, less attacks. So you can imagine that if you are having good security, then the attacks are minimized. The probability of attacks are minimized. Attacks, threats, directly proportional. More attacks happen if there are more threats. More risks, more attacks, more threats. Okay, more loss. So now let me tell you about the access control list. As I spoke just now, the rules, standard and extended. Of course, you can have a named access list also if you name it. There is functionally same as extended, but you have a name defined to a extended control list, access list. So here, as I said, the standard, you have only access or deny with help of IP address or your network address only, nothing more, or a system or allow or deny only to network or a host. But extended, you have IP, source network, protocol field. That is what, which is protocol means a service like a FTP, port, or whatever it is. You can define the number and then restrict accordingly. So this is how you can write inbound or outbound, the rule, where at the firewall, whether your members are sending means outgoing, whether any traffic from the internet means inbound. You can see that inbound, outbound. My people can send emails to others, but other persons cannot send attachments to me. So that mostly happens in corporate. If you are sending from outside world to any corporate email, they'll say, so don't send, it will not come. Anyway, the attachments will not come, it will be filtered. So that is what they say. But they can send attachments to you because they are from a trusted service. So they do like that. So the firewall will take care of everything. It's not written anything in the host. It's written in the corporate network firewall. That is the router. That is the gateway end. They do that. So these are some of the ACL guidelines which I have explained just few minutes. And how to write the standard access list, all these things also are mentioned. If any rule has a rule identification number, like even when you are in that road, if you are booked, he will try to tell you this according to so and so rule number you are booked. So if there is no rule number, they cannot give a challan. So same thing here also, we have a rule set. For every rule you have an identity number. If the identity number lies between 1 to 99, it is called as a standard access list. If the identity number lies from 100 to 199, we call as extended. And don't worry about the other numbers, we don't use at all. Okay, so 100 to 199 is extended. What happens if this 100 to 199 gets finished? You have still further from 2500 onwards. 2500 onwards. Anyway, don't worry about that. We have good amount of, here he is defining access list. 10 is a standard list. When you see the number itself, you can identify. 10 is a standard list. Anything above 100 to 199 is extended access list. So what you can define, this is how you can define access list. How you write a list in the router. After writing all the configurations in the routers, allowing the routing protocols, you can define this access control list. You can see this access list 10, the rule number 10, deny. He is denying this particular host. You can deny even network so and so 172.16.00, 172.16.30.0. He can, and all the hosts will be denied. Okay. So in this way, you can write a simple access control list in this particular network. Using packet tracer also you can do. This is standard ACL example. Okay, I'll tell you about how you can write extended access list also. In extended access list, I said about 100 to 199 will be there. Like you can say access control list 110, deny TCP, any, and also he has given port number 23. Port number 23 is nothing but telnet. Port number 21 is FTP. He has denied telnet service from this particular host to any of this particular one. He is blocking this particular port of telnet access so that the telnet doesn't happen to that particular remote server. So this is how, anyway, for you, it's not that much important about writing the rules. Just understand that the same router configuration, you write this access list. This is called as access control list. Okay. And rest all you can say permit others. First you write always in the firewall, the key line is write the deny rules at the top, allow rules later. If you write allow, it matches, it executes. Later if you write deny, it won't execute. Once the rule match happens, it goes through. It will not throw any errors. It will only, if it matches, it executes. So deny rules at the top, allow rules at the bottom. So in this way, these rules gets executed. This is about access control list. Okay. Any questions? So what is firewall voice traversal? I'm not very sure about voice traversal. Traversal means, going like a tree kind of structure. You can go to root areas or go into some locations, etc., etc. I'm not very sure about firewall voice traversal. Okay, firewall. Maybe in some context he might have referred. I do not know. I have to check and then let you know. The firewall basically is meant for writing the rules. Again, I tell you, Firewall, there are many type of firewalls. Like one is the network firewall, which we are speaking currently, and the other is host firewalls. Host firewalls are within your system. Your every operating system also has, even in your Windows also has your firewall. You can see this one. If you go to control panel, I'll show you. You have a firewall. Okay, but these are all host firewalls, not network. Whatever you write in this firewall will be, I mean, applicable only to your system, Here you see this Defender firewall. If you want to change the specifications, or if you want to allow or deny a particular network or a particular port, you can do that. See, like if you want to change this one, maybe you can go to advanced settings. And then you can create your own rules also. I'll show you. Yeah, so you can see this one, inbound rules and outbound rules are there. Like I'll show you inbound rule. I can add a rule also. New rule. I can set up a new rule. It is only rules. If you want to block a port, you can block a port. Change that port and say what is that, TCP or UDP. Specify a port. For example, if I say 5000, I'm giving something 5000. Say next. What do you want to do? Say next for all the things. Okay. Okay, next. I mean, you can give a name. Maybe you can give 1, 2, 3 and say finish. Where is this allow or deny? Where is that? Okay, allow the connection or allow the connections if it is secure. Block the connection. Means if you write a block, then automatically it blocks the 5000 port in your system. No entry, no one can come through that FTP, 5000 port. And if you say that next, finish, it is highlighted at the top that there is a block rule is allowed. Rest all things you can see allow rules. There can be even deny rules also, which is the block or allow or whatever it is. If there is no allow, then it is an indication that a block rule is there. You can again deny this particular rules also. But again, remove this particular rule. So, but again, I'm saying that this is for every firewall. Every system has a firewall. That is called as host-based firewall. And now what we are speaking is network-based firewall. Network-based firewall is within the router. If you write whatever is there in the router, all the elements which are there, all the what we call as sorry, all the devices which are connected in the network will have the same. Is this clear? That is some fundamentals which we have learned across about this firewall. Yeah, now I'll speak about the NAT. Okay, NAT is nothing but network address translation. I gave a little bit introduction about NAT previously, but now I'll be covering about what is NAT. It's a very, very important concept. Today's world, we have about private addressing as well as public addressing. Okay, so we spoke about private addressing and public addressing, right? What is private addressing? Any IPs which are range of 10 dot series or 172.16 to 172.31 or 192 series, all these things are called as private IP addressing. These are free addressing, and anyone can use. No one will stop you. Other than any of these IPs, you cannot have any other IPs. Now I want to have some fancy number 4444 or 3333 IP address. No, you cannot have like that. Those are public IPs. So you need to take permission, especially, or you have to buy. If you want to have a specific IP accordingly. So now those are internet communicable IPs. When you say internet communicable IPs means it can be communicated across internet, like a google.com or Gmail, Microsoft, Hotmail, or whatever it is. Okay. But whereas your LAN IPs means your 192 series or 172 series or 10 dot series. So as I said that intranet IPs are by default are not allowed to communicate with internet IPs. Those are different, these are different. So this network address translation will help you in order to communicate these LAN IPs to, what we call as the public IPs. How it is done? With help of NAT. This address translation is done. Suppose if I want to speak with a French guy, how do I do? I don't know French, and that fellow may not know Telugu or Hindi or whatever it is. So how do he do? So a person who is aware of both, I'll keep him as a bridge. So whatever I speak in Hindi or Telugu or whatever it is, he will translate. He'll translate into French and then he'll explain it to him. And the other way around, from the French he'll take the input and then he'll translate and then he'll pass it to him. Same exercise happens here also. This is called as network address translation. So in between, who does all these things? The router does. In your home also you have your home router. That is also called as an NAT router. What it does is that It has a private address pool from the DHCP, which is assigned to all the devices like your mobile phones or maybe your desktops or laptops or pads or whatever it is. So all the devices which are connected to internet has a private IP, only. Again, I'm saying, when you see the IP address, even in your mobile phone also after connecting, you will see a private IP. So that private IP is basically kept aside when any request is coming from the device at the router level. It has a public IP which is given by the service provider. With that public IP, it communicates to the remote end, that means to the internet, brings back the data, and then again it retains back to it, hands it over to the private IP. And after that, the translation expires. The IP, I mean the translation expires. One is called the inside, the other is called as outside. Inside NAT, outside NAT. Inside NAT means anything which is coming from private to global. Global is also again called as internet. The other outside is anything which is coming from internet to intranet is called as outside NAT. So both, there are two type of NATs which are there, inside NAT and outside NAT. Like this is classless interdomain routing. The original intention for NAT was to slow the depletion of the IP. You may say that why not we can give directly IP address to all the devices in the network address, like to all the devices in the network, the public IPs. If I start giving each and every one a public IP, you know that how many public IPs are available? 2 power 32. That is only 4 billion. It's nothing more. In the world, the population itself is more than what we call as we are more than about 10 billion. So no one will get. So we are more than 1,000 crores, right? Or a little bit more also, higher. So 10 billion. So where will we get the IPs if everyone starts using, and where will the servers come across? So in order to have less number of public IPs, we have this private addressing. Now you read this slide. So by allowing many private IP addresses to be represented by some smaller number of public IP addresses. So for the entire organization of even 2,000 people also, you may have 2,000 private IPs, but you may have only 2 or 3 public IPs. That is enough. You may be having a DTOM with a number of lab setup, maybe about 5,000 or 6,000 computers across the entire university. Maybe here, there. But imagine how many public IPs they may have. They may have about 8 or 16 or not beyond that. It's not required also. If you are hosting some websites or hosting some servers, etc., and that too, if it is publicly accessible, then only you require the public IPs. Otherwise, public IP address we don't use. So this is why the communication of NAT is, the protocol of NAT is very, very helpful. So you need to connect to internet, and your host doesn't have global IP address. So this will, your ISP will give you the public IP. From that, you can have the communication between your intranet and internet. So you can see this one, internet is here, your corporate is there, all your different departments are there. Your corporate has a NAT. All these people have intranet. This is public. So this corporate will act as a NAT, and then it brings the necessary data and hands it over to all the departments. You see this how it comes. You see, this is inside. This is internet. You see this, let me take this as a google.com, which has an IP 6347.3. 1.1, 1.2, 1.3, 10 series, all are intranet. So this is the corporate firewall which is there, which is also has a NAT protocol design. What will happen? This 1.1, here it is there. This has a public IP which is assigned by the internet 170.168.2.2, or it might have a pool also. This is called as a basic NAT. We don't use basic NAT now, because again, what will happen? 1.1 is mapped to 2.2, 1.2 is mapped to 2.3, 1.3 is mapped to 2.4. In this way, more number of public IPs are being assigned. So this has been changed to dynamic NAT. In dynamic NAT, what will you see this figure now? It has been changed. This is which we do now. Dynamic NAT, and also extension of dynamic NAT is PAT, port address translation. So remember this. I'll tell you the difference between, small difference is there in dynamic NAT and port address translation. The figure is same, 1.1.1, 1.2, 1.3, All these are your intranet. You have your hosts across. This is Gmail site and this is Microsoft.com, etc. via internet. Now, if 1.1 from here places a request to that he wants to connect to google.com, how it flows. You see this one inside. This is inside 10.1.1.1 is having a port of 10024. The request has been coming across. And from here, there is a translation happening. From here, there is a translation happening. It translates to 170.168.2.2, which is the IP which is allocated to him, to the same port of 1024, which has come from 1024. It has sent here to this particular one. Again, simultaneously, if 1.2 also comes, it will assign a different port. You have how many ports in a system? 2 power 64, sorry, 2 power 16. That is 65536 ports are there. There are number of ports which are there. Like port means a platform in a railway station. You can have more number of platforms, more number of trains can accommodate. Same thing here also. You have about 65536 ports which are there. A port can be TCP or UDP, which we have spoken. So here one port is 1024, the other port can be 1025, the other port can be 1026, which are unique. Or here 1723, the other can be in a different one. So different IPs are coming across, but here what is happening, you see, the IP is common, but ports are different. The ports are different. You see this? If ports are same, the ports are different at this global IP. Here you see, IP is common for all. You have only one IP. You have only one IP, which is sending it to the same. It can be google.com or it can be microsoft.com, whatever is the website which is there, and again it returning back. This is how this port address, I mean your dynamic NAT happens. So if you are using port as the medium of communication, you call it port address translation. If you are using a single IP, you are not using port 1, 2, 3, but the IP is only 2.2, 2.2 without any port, then we call as dynamic NAT, nothing more. But that is a bit slower. So naturally, but here in port address, you have multiple ports. Single IP also will work. Otherwise, we have to create a pool. Here you can see pool. A pool will be there. Within that pool, you can assign, and then each and every one will be getting a translation. This way is called as inside. The other side we call as outside translation. Okay. So we need to define in this particular way the script when we assign this one port address translation. Like that it works. Is this clear about this NATing? I have this only a simple demonstration. I'll share the slideshow later. Yeah, any questions you can ask me. Yes, absolutely. NAT is used to increase the number of private IP addresses. You can have multiple hosts, more and more private IP addresses, but only with one or two, very few public IP addresses. You can say to increase the private IP address or to decrease the public IP address. To decrease, to reduce, not to decrease, to reduce. Is this clear, Vamshi? Any other questions from anyone? Please ask. We have to continue with more topics. Okay, so that's all about this network address translation. I'll share these notes after the class. Okay, so now let me speak about the next one, which is IPv6. IPv6. This is also very, very important, and you might get questions also, and also for your academic interest also, which is understandable. Wireless LAN I'll describe during what we call as in cyber security. I'll discuss about that. So I will discuss about IPv6. So what is IPv6? Till now we were discussing in IPv4. I know these are something which is completely what we call as brain occupying technologies, but still we have to focus at one point of view. This is the current technologies which are running across. Fortunately or unfortunately, in the syllabus, all these things are not getting updated because I do not know why, but these things are current technologies which are happening, and most of the vendors who are there will be looking after. Do you know this? Do you know that? In interviews, they flood like questions if you are a real admirer to the interviews. Okay, and they'll not leave you also. If you are doing very good, they'll make you friends because there are very few people in the globe who are really into this particular domains. And then especially if you are one of them, they will not leave you. Under any cost, they will catch you and then they will again bring an offer to you at all times. But you need to be a good knowledge seeker in these areas. So V6, you know that V6 has come across, not some people say it is version 6. I do agree till the name version 6, but don't ask me when version 7 is coming or when version 8 is coming. It's not meant for versioning, even though it is called as version 6. So all of a sudden, and let me also tell you, there is no concept of version 1 or version 2 or version 3 and where is version 5 and when is version 7 coming. No, it's not the A chart here when we say. Here when we say V6 version 6, we have only version 4 and version 6. Why we have said V4 as version 4? Because of 4 octets, 4 8s, that is 32-bit. In the header, we have 4 8s, 4 octets, we call it octets for V4. But whereas in V6, we don't have 6 octets. We call it hextets. We call it hextets. Here, we don't use binary, sorry, we don't use decimal. We use hexadecimal. In V6, hexadecimal. And the number of bits has been extended, not from 32 to 64, but it has been extended up to 128. Why not, sir? Why it has not gone 64 and 128? So no one wants to take a risk again, upgrading from time to time and again. So 64 means the maximum address is 2 power 64. So 2 power 64 is not a big number for us to think. So then they thought, okay, let us have 128. 128 is a very big number. 2 power 128 means we cannot imagine. I will tell you how you can imagine what is the value of 2 power 128. You know, we are living on Earth, right? We are living on Earth. Take the square feet of Earth. Square feet of Earth. Okay. Imagine that there is a figure called as this much has come. Okay. The square feet. Divide by 4. That many IPs you'll get. Maximum. That divided by 4. So that means every 4 square feet of Earth where you are living, you will get an IP. Every 4 square feet. That is how you can simple. How much big is your house? Oh, my house is as big as a cricket ground. Oh, that much big. Now I understood. Like that. It's only a comparison. So IPv6 has a very big address space. Very big addresses. If you want, you can give through a calculator what is 2 power 128 value. You will get that number, that many number of IPs. So why IPv6? The only answer is you can see that it's created the answer to IPv4's inevitable looming address exhaustion. So whenever the exhaustion happens of IPv4, it is inevitable that you have to have V6 address space. So as we have seen about why IPv6 address, we saw about that, and the number of bits is 128. And again, the numbering system is not decimal, unlike V4, and do not ask question also when will V6 or after V6 what. V6 is good enough for the next 50 years or at least 70 years. That will complete our generation. Okay, especially in the areas of networking. Okay, so not that afterwards we really require. No, that is sufficient. That is sufficient. That every 4 square feet one IP means how many square feet? Even if for a family to live also minimum 600 or 700 square feet is required. Minimum of minimum, whether you are living in a costly environment or etc. So even that place also you are getting 100 to 200 IPs per person or per location. So here we are using hexadecimal. You can see this, every hexadecimal, I can tell you in this particular way. Like here, the total 128 bits is 16 colon 16 colon 16 colon 16 colon 16. Like this, 128 bits has been spread across. Okay, 128 bits has been spread as 16, 16, 16, 16. So the 16 bits, one F is 4 bits. F. Sorry, 4 Fs is called as 16 bits. 0 F is nothing but 15 in your decimal. F is nothing but 4 ones. 4 ones is F. So 4 ones like that. 4 Fs means 16 ones. So address can have up to like this. FFFF. Sorry, not 4. Here you see this in this way. You can continue to FFFF. Whether you write in small or caps, it doesn't matter. It says the same. You can see the address coding is like this. So now coming back to this one. So the address looks like this. Here there are some rules for you to understand in V6. Here there are some rules. You can have each and every what you call as hextet is differentiated or separated by a colon, not with dot. In decimal we have a, sorry, in V4 we have a dot. Whenever you see colon, it is very clear that it is an hex. Okay. Now coming back. So here, if I want to write an address like 0123 colon 5678 colon 0000 colon 0000 colon, maybe again once again I say 3456 or maybe A90A, okay, colon 0000 1 2 3 4 5 6 7 like this, colon maybe I can say A2 3 4 like this. This is the address which I have written simple. So this you can write it in a way 1 2 3 colon 5 6 7 8. The starting 0 is not required. Similarly 0 colon 0 2 3 4 5 colon A90A colon 0 colon A2 3 4. Like this it can be cut shorted. And again there is more simplicity, which is 1 2 3 colon 5 6 7 8 colon, this 2 zeros can be nullified and written as double colon. Whether it is 2 zeros or 3 zeros or 4 zeros, don't worry. You can add simply a double colon. But remember that there can be only one double colon across. There can be only one double colon across the entire IP range 2 3 4 5 colon A90A colon 0 colon A2 3 4. Okay, this is how I can simplify my address. Suppose if I replace this address to something else, like I'll say like this, maybe this one also is 20000. This one also is 0000. How it will be replaced? You see this one. This will be replaced to say like this with 2 3 4 5. This one also with 0, and finally again this with, there is no concept of triple colon. Still the address is like this. Is this clear? Still the address is like this one. 1 2 3 5 6 7 8 colon colon 1908 colon 0. It will understand that out of the total octets of 8, the three hextets are lying in between with zeros, only for zeros. Okay, I'll give another example of this particular one. So here I have an example like this. So, but I will replace this one with 0000. Also, I mean, I will replace this one with maybe A123 and this one with 000 and with this one as 5 6, something like this. Like this, I have given an address. Now, how this is going to happen? This one 0 0 A123 colon 0 colon 0 colon 056A colon A234 in this way. So here you have a choice of having double columns. How you can write 0123 double colon A123 colon. You cannot write two double columns. The rule is only one double column. You have to write 0 colon 0 056 A colon A234. Like this you can simplify it. You see here now reading this IP address, you'll understand better. You can see this one, two double zeros are there replaced with a double column. The rule is only one double column can be there. Whether you have 2 zeros or 3 zeros, it's okay, no problem. So now if all zeros are there, then you can say colon colon, that's all. Colon colon, if all zeros or all zeros 1 is equal to colon colon 1. All zeros, 7 zeros, colon colon 1 means 1. This is equivalent to 127.0.0.1 LO of IPv4. Yesterday we did that. V6 you call as colon colon 1. Okay, you can see this CMD. If you say ping hyphen 6, ping 6 or ping hyphen 6, ping hyphen 6 colon 1. You say that it will, this is LO, this is LO, local interface. Okay, so that is how you can. Suppose if you do not know how you can convert your V4 to V6, you can write it in this way also. Last 2 octets, the hex states you can remove, and you can give your current IP address also. That's what people do. They'll write all zeros and with colon their current existing IP address in decimal itself. See, again I tell, V6 can understand V4 addressing because it has come later. V4 doesn't know about V6. While writing V6 addressing, you can mix it with V4 address also in decimals. If you are writing in decimal, it will think it is a V4. If you are writing in V6, I mean columns, it will think it has, say V6. Is this clear? There are some addresses which are called as reserved addresses. FE80 is private addressing, which we use it for local, like your 192.168 or 10 dot series. We use this FE80, that is linked local unicast. And also you have multicast also, FF00, like 224 series onwards to 239 we can use this multicast. And reserved for examples and documentation means from 239 to, 240 to 255 you have the same thing, you have 3FFF and examples and documentation. This is also called as 2002 is also called a tunneling system if you want to migrate. Tunneling system if you want to migrate. So certain servers which are again brought in about maybe 30 years or 25 years onwards they are running. They don't want to change the IP address. But you see, I'll tell you where it is being used. Your entire mobile system, how you are using this mobile system connecting to internet, the end clients which are there, the mobile system, this has an IPv6 address. But you can still connect to google.com in V4 or you can connect to any servers in V4. So V6 can understand V4, no need to change. But V4 cannot understand V6. Okay, that is the probability. So this person can tunnel the IP of V6 to V4 and then bring back the data to V6. That is called as a tunneling system. So there is a mechanism of that. Using V4 network addressing system, the V6 also can understand. Like I'll show you how you can assign, like this is my local area network, right? This is my local area network. Where is this? Ethernet. Network and share, not this. You see this Ethernet. How do I assign my V6 address? I'll say properties. You enable this V6. Okay, properties. You can write it here. Already I have written here FC00 colon 10 colon 100 / 112. My gateway is so and so. Just already it is validated and executed. So you can see this when you say C prompt. When you say IF config. Sorry, IP config. In Windows we say IP config. In Linux we say IF config. You see this one. V6 also is coming across. You see here. In Ethernet adapter FC00. 10 colon 100, which is assigned already here. You see this one, FC00 10 colon 100. The same thing is displayed here. The same thing is displayed. I have V4 address as well as V6 address. If you want, you can communicate with this otherwise not. If you have a DHCP V6 address, it will obtain the V6 address also automatically. Is this clear? Yes or no? Please ask questions. Please ask questions. I'm trying to give as much information as possible. Yeah, please ask questions. So this is about V6 in short. You can assign your network about V6 address also. Yeah, any questions, please do ask. So we have covered about V6 also in our today's class. So you can see this. Please be prepared. Tomorrow onwards, we will start cyber security. But if you focus network essentials properly, you can easily become a cybersecurity administrator. Even in cybersecurity administrator, if you are selected also, they will ask you to focus more towards networking and understanding about networking. Because the most of the time you will be doing, scanning of ports, scanning of, IP address networks, etc. vulnerabilities, or maybe focusing towards penetration testings of applications, etc. So if you are doing vulnerabilities, naturally you should understand the network very clearly. Okay, so this is our agenda. So up till this point, we have completed. I mean, this 21.1, this is today's. Okay. Yeah. Any question? I have opened my chat box. Please ask. Please ask. V6. How you can assign your V6 address and how V6 address is also used. So I have seen several people working in networking for the past 10 years, but they don't know about V6 addressing system. Because of simple things, they will be losing sometimes in interviews also. Because this is a winning shots, very easy to understand and very easy to implement also. But unfortunately, people are not migrating to V6. Some of them, especially the network administrators. Okay. So also one more thing which I want to tell you before closing for today's topic. Yeah, I wanted to have a questionnaire, but since number of topics are more, I'm not taking up questions today. But I will take up questions definitely. Where is this? One second. Okay, these are the questions which are there. With answers also I have mentioned, but try to, I have already given questions in yesterday's mail. Please go through these questions. Maybe we'll have some discussion on these questions also. These are self-explanatory. What I suggest is that please go through what are the layers of OSI. You can answer backbone, LAN, node, routers. Okay, even you see, as we have created a WhatsApp group also, not only it's always required to ask only in the classroom, you can ask even in WhatsApp also. I'll try to figure out an answer. At least I'll take that question and then I can immediately start answering the question during maybe like what we call as before the class or during the class or whatever it is. Okay. The subnetting also I will refer during the course, but not now. Subnetting is nothing but dividing a larger network to a smaller piecing. You are dividing into a larger network to small pieces of network is called as subnets. So in earlier days we used to do subnets, but nowadays we use mostly what we call as VLANs. VLANs will solve the problems, but still subnet is essential for us. I'll be discussing that and I'll be explaining a little bit about subnet. But till that time, understand that subnet is a part of network. IBM has a big network. For example, if I say under that you have multiple subnets which are there, multiple subnets. So this is how you can say subnets which are there. I'll demonstrate. I'll explain about that. So anyway, these are all physical things, typically 90 to 100 meters. What is data encapsulation? Gunshot questions. Network topology, we spoke about that. VPN, we will discuss about that. VPN also. Virtual private network. I can explain about that. VPN also. Like VPN is again a part of network. I'll just take this notepad also. So recent days, the abbreviation of VPN is virtual private network. Okay. Recent days, you are seeing all the IT employees working from home. Okay. Working from home means the only network which you have is untrusted. The only network which you have is untrusted. So how do you expect a client really to work across on an untrusted network? That too with a trusted resources. Did you get my point? Those are all basically to work in any project. You see all the people are working across internet, and that too they are connecting to the live servers across an untrusted network. No, they are not doing any through untrusted. They are connecting to through the VPN to the destination, and then what happens is that from the destination the servers are accessed and then they do their task. What happens in between? For that, what they are doing is that, like you are going on a public road, suddenly you are entering into a tunnel. Once enter into the tunnel, you have to have either an exit point the other side, or only you have to get out from your home place. You cannot come out from in between. Same thing also in virtual private network. Once the route is established from the source of, once you sign in from the source to the destination, there will be a socket which will be established, All your data pumping from your local system should go into the socket and exit to the customer's place. Believe me, once you sign in, even VPN, you cannot access internet, even though you are on internet. Is this clear? You are accessing internet as a media. Once the route happens, you are landing only into the destination. You are like entering into a tunnel. You are entering, you cannot exit even though the world is there with you. So the data goes inside in a secured mode to the destination, then it gets released. Otherwise, disconnect the tunnel, disconnect the VPN, and then you can access the internet. Once you are signed into the VPN, you ask your friends, once the VPN is signed, can they access internet? Sorry, no, they cannot access internet. If they want to access internet from the client's location, if they have internet set up, then only they can access, but not directly. They will not have access to the internet. So in VPN, you have two types of VPN. One is site-to-site VPN, and the other one is off-site VPN. Site-to-site VPN is between corporates. You are working in an IBM center in Bangalore, and you might have a client location somewhere. Maybe if I say like ExxonMobil, a pharma client somewhere in Netherlands, or maybe a Saint-Gobain in France, a glass company. Okay, the client may be sitting there. So how will you connect? How will the client really understand that you are sitting in a trusted network also? All they know is that, oh, okay, you are sitting in Infosys somewhere in a Bangalore location, or they may know that you are sitting in an IBM campus somewhere in Bangalore, but they have not seen that. So, but they have their network, which they need to keep their network safe. Their network is nothing but, it can be in France or Netherlands. If something happens, they cannot come to Bangalore and then they can catch the employees. Their share market will go down, everything will go. They have to close the market if some hacking happens or some unwanted transactions come into effect. So what they do is that they have a site-to-site VPN. Whatever traffic is coming across from Bangalore or from Chennai or from even what we call as office. I mean, this is office. Bangalore or maybe Hyderabad or Pune or maybe Mumbai or Chennai or whatever it is. They have to first sign in. That is called a site-to-site VPN. After signing in to the VPN, from this site to their site, they are connected like a leased line. It is not internet line. They are like a leased line. So once they are into the site, they can access the resources of the client end. In that way, that is called a site-to-site VPN. If that will enable the trusted network more trusted. A trusted network more trusted. This is one kind of VPN which is there. Okay. Which is when you are in a corporate office. The second one, when you are at home. So normally today we are using this offsite VPN. In offsite VPN, what happens is like you are signing from the internet, and then you will be using an internet. I mean, you are using a routing client. Like it can be a Cisco routing client or a VPN client. Okay, software. Once you execute that, you will be asked with a two-factor authentication also, like a VPN or a secure code or a magnetic tape or something like that. Once you give that authentication, it will try to establish a route from your end, from your home internet end. There is an internet facing servers. It will authenticate, it will validate, and then what it establishes a route from beginning to end, and then it allows to the other end, which can be a corporate destination or any other thing. Today, some people are also using this VPN for a different purpose also. Suppose an internet site is banned in our country. It's not using because our routers enable certain websites. Certain websites may be banned. So you can even take up using a VPN, sign in to that particular country, establish, like we can take a France VPN or maybe connected to France, or maybe connected to a different country like Nordics or maybe Australia or something like that, and access the other websites also. Some people do that. That is called as proxy VPNs. Proxy VPNs means that our internet servers will not, our internet gateways will not come into the picture. The gateway, once you sign in to the VPN to the remote end, those gateways will come into the picture. And whatever that gateway has, that gateway is nothing but a router. The routing tables, it will execute accordingly. Whatever their country rules follow in that way. That also people often do this particular. Is this clear about this VPN? Virtual Private Network. Okay, a technology that allows secure tunnel to be created across networks such as internet. For example, VPNs allows you to establish secure dial-up connection to a remote server. Dial-up are the olden days, but today we use even two-factor authentication also. Okay, NAT also, we spoke about this. This is a protocol that provides a way for multiple computers on a common network. So instead of saying a common network, you can say a private network to share a single connection to the internet. It's not single connection, it can be even to share connection to the internet, that you can say. Okay. I mean, if you are using a single public IP, you say single connection, the possibility is that NAT can have even multiple public IPs also. That's why I said that single may or may not. So please go through these questions, ask me. We'll also have some time for review of all these things. RIP, which we spoke about this particular one, and different ways of NIC, network interface card, wide area network. Some things which are known to you, but certain things which are there. Proxy is again a good question. Please go through this particular one. Function of an OSI layer. Okay, go through this one. We'll also review and we'll have questionnaire also. Yeah. Any questions before we log off for today? There is a question. Yeah, I'll share the questions and answers also in the Google Drive for today's. So try to. Okay, the answer. Okay, so I will share the questions of today and also the recordings in day 3. Okay, so please go through all this. See, one more thing also, I'm saying that please focus this 10 days. It will be advantage for your career. It will be advantage career. No doubt, I am speaking all these things with my experience. It is not only with help of books you will be able to understand each and everything. You can ask direct questions. You may say that there are books, there are YouTube videos, Udemy videos. Oh, okay, there are a lot of things which are there. But only thing is that we have to learn all these things. So this is a first hand. You can ask questions directly, listen briefly. You will have good bandwidth and also understanding. I have seen several people winning who has learned across, I mean, with my training. And then even today, they are earning more than even 15 or 20 lakhs also. There are such type of administrators also. You can be one of them because there are very few people. The competition is very less. Suppose if there are 10 positions, do you think that 100 people will be there? No, less than around 20 or 25. So it is very easy to occupy. But whereas for other programming areas, if there are 100 positions, you can see more than 1,000 people also competing for that. So it is like that. It's like that. The winning ratio is very, very less. I mean, if you are having multiple technologies, you will be called. You will be called. I have seen several people chasing also for joining in their companies if you are good enough. So this is one area. Why I speak is that Java may come and outdate with a new technology, but networking, even the past 30 years, good or bad, I have chosen this technology when I did my engineering, but till now it is giving me food. Till now it is giving me food. It is rest assured. This technology, you can enhance a little bit more and more, but definitely it will give you a good career, at least for the next 30 years. I can say that. Why? Because the only reason is that as long as internet is there, you can have, I mean, network will be there. Networking career will be there. So cyber security will be there as long as internet is there. That also is linked in. And more technologies are coming ahead. We can focus on these things also. It will be a royal career. Once you choose this, only thing is that you need to keep some interest and understand the protocol architectures of each and everything. For everything, there is a solution. Only thing we have to dive across and bring out the solutions. So that's all from me now. Is there any other specific question? Yes, I can answer. Otherwise, yeah, you will provide the answers as well. Yes, I will provide the same document in the Google Drive. Okay. Yes, yesterday I have kept that questions, but no one asked me question also. I do not know whether you are reviewing or not. You have to take these days as very serious days because you know the countdown has started. It's not many days. Even like last year and before last year, I have seen several people competing each other for getting these positions. And at least, of course, I think last year there are about 37 members who got selected, and before 33 members got selected before last year for one, I mean, cognizant interview. So I think this interview also, this time also, they are supposed to take not less than 50, I think. If you are doing, if you are not doing, sorry, they don't take any choice of no, we have to take it compulsory or not. So, and even I think in one of the sessions while I was doing a program, I think the interviewer also came for during the class. I think once she gave importance of cyber security, how this will be helpful for the young entrepreneurs like you, and the focus area during the internship days. I think. So the only bottom line what she says is that you should have good technology skills and of course good communication skills and the right way to give the solution of a problem. If you have all these three, no doubt why you should not be selected. You should come out with the selection. Okay, that is the key lines which has been mentioned. So focus accordingly.